I love the way rhinos look. They look like an armored tank.
They actually just have really thick skin. I think it looks like armor because they're almost hairless.
Do they have any hair? I can't see from here.
Well, they have eyelashes and a little in their ears and some on their tail.
I wonder why their horn is so short.
Well, it says here that rhinos rub their horns to shorten the length and that their horns grow throughout their lives, like a fingernail.
I wonder how long they live.
Well, it doesn't say on the plaque, but I think we could make an estimate using the body mass hypothesis.
Body mass hypothesis? Does that have to do with dieting? Because that rhino looks a little overweight to me.
No. The body mass hypothesis has to do with the average body mass of a species. It says that the bigger the species, the longer it lives, on average.
Okay, so the bigger the animal, the longer it lives. That makes sense.
Biologists have been studying this, and they've developed a model for making an estimate. You take the body mass and raise it to the power of 0.2 and then multiply by 6 million.
6 million? That's a lot of years.
Yeah, well, the formula gives you the answer in minutes.
Oh, that makes much more sense. So the rhino on average weighs 1,600 kilograms for the females.
Yes, whoa. So that gives us 26,240,000 minutes.
How many years is that?
Approximately 50 years.
Wow, that's a really long time.
Yeah. You know, there's another interesting hypothesis based on body mass.
What's that?
The heartbeat hypothesis.
The heartbeat hypothesis. Now, you would think that having a heart would be a fact and not a hypothesis.
Yes, having a heart is a fact. But the heartbeat hypothesis says that an animal's heart rate is indirectly related to its body mass.
So the bigger the animal, the slower the heart rate.
Exactly. Haven't you ever felt a kitten's heart rate? I mean, doesn't it feel a lot faster than yours?
Now that you mention it, you're right.
Yeah. Well, biologists have studied a large number of animals for the heartbeat hypothesis, and they've developed another model to help predict the average heart rate for a species.
But wait, what does this have to do with lifespan? Because right now I'm learning about heart rates.
Well, combining the two hypotheses will give you the number of heartbeats during an animal's life.
Whoa, okay, explain this to me.
Well, you have the heartbeat hypothesis, which gives you a heart rate in number of beats per minute.
Right.
And then you have the body mass hypothesis, which gives you the number of minutes in an animal's life.
Okay.
So multiplying the beats per minute times the number of minutes, you'll get the number of beats.
Okay, so that makes sense. Since both are related to body mass, the combined model is a function of body mass alone.
So for our rhino here, a heart rate is given by 241 divided by the body mass, in this case, approximately 1,600 kilograms. And that is raised to the power of negative 0.25, which gives us 38 beats per minute.
Times 26,240,000 minutes.
Roughly a billion heartbeats.
A billion heartbeats? Wow, I wonder what it comes to for other animals.
Well, let's collect some data and see what we find.
Let's do it.
Let's do it. So we've collected a lot of data, and it's pretty interesting.
So it turns out that the smaller the animal, the more heartbeats they have in their lifetime.
And you can see that the bigger and bigger the animal gets, the closer the heartbeats get to just 1 billion.
So should I go on a diet?
Why? I mean, you can see right here, the bigger you are, the longer you live.
In that case, let's get a milkshake.
Well, this is an average for species, so it doesn't apply to individuals.
Yeah, it doesn't matter. I really want a milkshake.
You
Come
too.
on.